Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. So I am Jeetendra Dixit. This is my profile. So I'll continue. Let me check my voice whether I'm live or not. Yes, I'm live now. So I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. Yes, voice is also okay. Perfect. Everything. Alright, so today we are going to continue quadratic equations and we'll do graphs of quadratic equations in this session. We'll understand all types of possibilities of graphs of a quadratic equation, quadratic polynomial, and we'll do some practice questions also based on graphs. But before starting, let me tell you about the Unacademy subscription. Alright, so as you know, Unacademy is India's largest online learning platform, and once you can prepare for many exams on this platform, but if you are preparing for IIT-JEE and you take the subscription, then what are the things you can access? Let me explain all those things to you. So when you get the subscription to IIT-JEE on this platform, Unacademy, then you get access to daily live classes of all the educators. All means all physics, chemistry and maths. And then you can follow a set of educators of your choice. That's up to you. So you have complete freedom. You can attend anyone's lecture. Everything will be, this unlimited access will be given to you. You can watch their live sessions as well as recorded sessions also, right? So you can download recorded sessions and watch them later. You can ask your doubts during the live sessions only, and during the live sessions you can ask doubts through chat, or you can send images also. There are awesome features on the platform, and you can be familiar with these features by attending the special classes. The special classes are completely free. So you can just go on the platform, download the application and attend the special classes. So all these special classes you can see will be available for you without taking subscription, and after attending the special classes you will come to know how interactive this platform is. Alright, live tests and quizzes will also be available for you once you get the subscriptions. All tests and all quizzes. Alright, and all these courses are well structured means everything is pre-planned. All the schedule you get to know in the well in advance, like upcoming session of which topic, which faculty, which particular date. Alright, date wise, time wise, so everything is pre-planned. Alright, now let me tell you how to take the subscription. You can download this Unacademy's learning app from Play Store, and after downloading you can buy subscription for 1 month, 3 months, 6, 12 and 24 months. This is the current price list, which is going to change from 10th of September. So only 3 days are left. Alright, only 3 days. In fact, if I exclude today's, then only 2 days are left. Alright, so 12 and 24 months you can see is still 27,000 and 32,400, which is very low, right? You can compare these two prices. Now this is the new price list. You can see now the 1 year price is going to be this 34,650 after 2 days, which is this now. Alright, after 10% discount. And this is going to be the 2 years price, which is 32,400 now. You can use JEET1, my code, alright, to get instant 10% discount. So if you are taking subscription in next 2 days or today, you'll get these prices for 1 and 2 years respectively. Alright, so this was about the subscription. If you haven't taken it yet, then hurry up and take it now. Alright, so now let's begin the session. Quadratic equations, graphs of quadratic polynomial. Alright, let me check my voice once again before starting. Seems perfect. So I'll start plotting the graphs of a polynomial y is equal to alright. So this is the quadratic equation, you know, right? A is not equal to 0. We need to plot this graph. You have already done the graphs of linear equations, right? if I ask you the graph of y is equal to ax plus b, right, or mx plus c, then it looks like it is a straight line, right? You all know this. If a is positive, line will be like this. If a is negative, line will be like this, right? A is positive, a is negative. Okay. This can get cut y-axis anywhere. Depends b is positive or negative. So in this case, b is positive. I have taken. So it is cutting somewhere on the positive y-axis, right? But now we need to draw the graph of this quadratic. So how would we plot it? First, I'll express this quadratic equation as y is equal to perfect square, which we have done in the beginning only, a into x plus b by 2a, the whole square, minus d by 4a, all right, d by 4a. You can plot the graph of y is equal to y plus d by 4a divided by, sorry, is equal to a times of x plus b by 2a the whole square. So we need to plot the graph of this. We'll reach to this point, but let's start with very basic graph of a quadratic. That means graph of a monomial only, all right? So if I ask you to plot the graph of y is equal to x square, see how would it look? Okay, so see y is equal to x square. If you put x is equal to x is equal to 0, y will be 0, right? Let's put some points and check the values. If you put 1, you'll get y is equal to 1. So 1 comma 1, right? If you put minus 1, then also you'll get minus 1, y coordinate will be 1, right? So whether you put plus a or minus a, you'll get the same value of y. So if I say this point, that all the points which you're getting right side of the y-axis will get the same points on the left side of y-axis also, and they will be symmetric, right? If you put 2, you'll get 4. If you put minus 2, you'll get minus 4. And if you join these points, then graph of y is equal to x square looks like this, all right? So this is called a parabola, which you'll learn in coordinate geometry, parabola in detail. So this shape, all such shapes are parabola, but parabola shape is like this, all right? So quadratic equation always represents a parabola. There are some conditions also for parabola, but we are not going to learn those conditions now. We are just looking at the graph of y is equal to x square, all right? So this is the graph of y is equal to x square. If I draw it separately, all right, this y is equal to x square. See what will happen to the graph if I plot y is equal to x minus 1 the whole square. If I replace x by x minus 1, then see what happens. You know this is the graph of y is equal to x square. When you replace x by x minus a, graph shifts by a units towards right if a is positive or towards left if a is negative. So that means this graph is going to shift rightwards by 1 unit, all right? And this point is called vertex, all right? This point is called vertex. So this vertex is now going to be at 1 comma 0, all right, here. So new graph of this curve y is equal to x minus 1 the whole square is going to be like this, all right, like this. All right. Now see what happens when you, if I ask you to plot y minus 2, say, now I'm putting y, I'm replacing y minus 2 is equal to x minus 1 the whole square. You can also read this equation as y is equal to x minus 1. Let's see how the graph of this equation will look, all right? So it was already shifted. We were here, right? This was the second graph. Now we need to plot the graph of y is equal to x minus 1 the whole square plus 2. So this whole part x minus 1 whole square plus 2 because you are adding plus 2. So you are getting y is equal to 0 in this equation when you put x is equal to 1. So this point was 1 comma 0. But now when you put x is equal to 1 in this, you'll get 1 comma 2. So this vertex will be now at 1 comma 2 somewhere here. This is 1 comma 2 and this graph will go up. So this is the graph. So now you can see whenever you have such equation y minus k is equal to x minus h the whole square, all right? Then graph of this parabola, what is the vertex, by the way? What is the vertex? You can see, you can compare with this. Vertex of this will be h comma k. So you just need to plot the vertex, all right? And this will be like this, upwards. It might be downwards also. I'll tell you when will it be downwards. Suppose you have y is equal to minus x square, all right? Okay, let me give you some more examples before proceeding. So if your y is equal to say 2x square, y is equal to 2x square also look the same. It is the same curve, right? A slight change in the values, x square will be below this, 2x square is above that. In general, you can say y is equal to ax square. Graph of this will be upwards parabola. This is called upward parabola when a is positive, and downwards parabola, it will be like this. See, all the values of y will become negative if a is negative, right? So if a is negative, it will be just the reverse. I mean, image of the first parabola, which was upwards about the x-axis, about this line, all right? So this is the vertex of both the curves, whether a is positive or a is negative, is at 0, comma 0. And if I generalize it, then y is equal to a times of x minus h the whole square plus k, all right? Just assume that h and k are positive, then graph of this curve, I mean, where will be the vertex? Because you're replacing x by x minus a, so graph will shift towards right side of x-axis by a units, and because you are replacing y by y minus k, you can read this equation as y minus k is equal to a times of x minus h the whole square. Y by y minus k, so graph will go up if k is positive, all right? So the vertex will be h comma k. You can see h comma k satisfy this equation. So h comma k is the vertex, all right? And it will be upwards. It will be upwards, depends on the value of a, all right? A. So if a is positive, that means transformation has been done to this graph, and now it has this vertex which was at 0, comma 0 for this curve has reached to point h comma k, all right? But if a is negative and h and k is still positive, let's take the same point like here. This is h comma k and a is negative. A is negative, so this graph now will transform. So it will be this graph, this downwards graph, this part, all right, this part, this graph will shift towards h unit, shift rightwards by h units, and upwards by k units if we are taking h and k positive. So graph will be a downward parabola like this. It's called downward, all right? So it will be upward or downward, that depends on the value of a. That depends on the value of coefficient of x square, all right? So this will be these are the graphs of a quadratic. I hope so far it is clear. Now let's plot the graph of y is equal to ax square plus bx plus c. We can write this quadratic equation as a perfect square, and we can write y is equal to a times of x plus b by 2a the whole square plus dy 4a, all right? Then you can write y minus dy 4a. I'm writing like this so that we can compare with this, all right? We can compare it with this equation or this. Same thing. Same thing. The only difference is that a is positive in first and negative in second. We have considered. So it will, according to that, it will be either upwards or downwards, all right? So y minus d by 4a is equal to a times of x minus, this also you can write x minus b by 2a, okay? The whole square. So if you compare, this is your key, vertex is vertex of this parabola. First of all, let's write the vertex. Vertex of, if by comparing with this, vertex coordinates of vertex of this parabola are minus b by 2a, this is x coordinate, and y coordinate will be minus d by 4a. So this vertex can be anywhere in first quadrant, second quadrant, third quadrant, or fourth quadrant. That will depend on the value of a, b, and d, right? Discriminant a and b. So if I take, don't plot x and y axis, just plot this vertex. It might be anywhere, okay? So two types of graphs are possible. If a is negative, phase negative, graph will be like this. All right. Graph of this equation, equation number 1. And what is this point? This point is vertex V. So let's write V. And if A is positive, then graph will be upwards parabola passing through this vertex. Okay, this will be the lowest point. And when it is downwards, this vertex will be the highest point. All right, on the graph. Okay. Now, according to the values of A, B, and D, let's see how this graph will look like with X and Y axis, all right? Whether it will cut X axis, whether it will be above X axis, or whether it will touch X axis, all right? So we can make various cases, and these cases are important. That's why we are doing it. So let's see. So I'm making some cases in which I'm just plotting the x-axis because I'm interested to know whether this graph is above x-axis or below x-axis. Okay. So I'll make first 3 cases and explain you the importance of these 3 cases. All right. And 3 lines because I'm going to make 3 cases directly. So this is your x-axis. All right. First case, second case, and third case. All right. Now, what are these cases? Let me explain. So in first case, let me write the equation first of all. So equation is y minus dy, oh, sorry, y minus d by 4a, all right, minus d by 4a is equal to a times of x minus b by 2a the whole square, all right. Now let's see. In the first case, when a is positive, so a is positive in all 3 cases. That means we are drawing the graph of upward parabola. All right. So by looking at the value of a, immediately we have come to know that graph will be upwards. Okay, it will be opening upwards. This is called the opening. This is called opening of the parabola. So it is upwards. All right. So by looking at the value of a, we have got to know that it is upwards. Now, whether vertex will be above x-axis or below x-axis, that will depend on the value of minus d by 4a. If minus d by 4a, which is the y coordinate of vertex, y coordinate, what are the coordinates of vertex? Minus b by 2a, comma, minus d by 4a, okay? These are the coordinates of vertex. So if d is positive, all right, and a is also positive, the first case, so you know when d is positive, then equation ax square plus bx plus c is equal to 0 has 2 roots, 2 real roots, real and distinct. That means if you put y is equal to 0 in this equation, then you'll get ax square plus bx plus c is equal to 0. And you'll have 2 real and distinct roots of that equation. Okay, I'll explain that point also. So when d is positive, a is negative, minus d by 4a. What will be this? Positive or negative? This is positive, and minus sign is there, so this will be negative. That means point vertex is below the x-axis and graph will be like this. So graph will cut the x-axis at 2 points, and where this cuts the x-axis at that point, y is 0, y coordinate is 0. That means ax square plus bx plus c is equal to 0 has 2 real roots because this graph cuts the x-axis at 2 distinct points. So that means for these 2 values of x, y will be 0, right? In this equation, y is equal to ax square plus bx plus c. So you can say ax square plus bx plus c is equal to 0 has 2 real roots. 2 real roots. All right, so it's going well. So what I was saying is this, that whenever you have discriminant positive and a positive, discriminant positive, you know that ax square plus bx plus c will be 0 for 2 real values of x, and we can see on this graph, then these are the values where ax square plus bx plus c is going to be 0. And for values outside these 2 numbers, that means before before alpha and after beta, ax square plus bx plus c is going to be positive, and between alpha and beta, for any x between alpha and beta, ax square plus bx plus c is going to be negative, right? So is sign going to matter, all right? Now let's take the second case when a is positive but discriminant is equal to 0. So when you see discriminant is 0, that means minus d by 4a is going to be 0. When minus d by 4a is going to be 0, that means this vertex will be here, somewhere here, on the x-axis only. So graph will be like this, and it will touch the x-axis. Yes, in this case, roots are equal, roots are repeated. Roots of which equation? Ax square plus bx plus c. And also you can say that ax square plus bx plus c. You can see this graph is always above the x-axis. That means y coordinate is always positive or 0 for this point. And what is y coordinate? This is the y coordinate only, ax square plus bx plus c. So you can say this expression will be more than or equal to 0 for all x. I think it's good now. Yeah. All right. So this is the third case, and third case is very important. We were discussing the third case. So in third case, the graph is you can see this graph is completely above x-axis. That means y is always positive. And y means what? That means ax square plus bx plus c is positive for all values of x belonging to real numbers. So whenever in a quadratic a is positive and discriminant is less than 0, then ax square plus bx plus c is always more than 0. So if they ask you this question that this quadratic equation is always positive, then find the value of some parameter, then you can, like, let me give you one example here. If they ask find lambda if x square plus lambda x plus say 4 is more than 0 for all values of x belonging to real numbers, all right? So how would you proceed? You know that a is positive in this, already a is positive. You just need to make discriminant less than 0, and this expression will always become positive. All right. So a is negative in this case. In this case also is negative. In this case also is negative. So that means graph will be downwards. Now whether it will cut x-axis or it is below x-axis or it touches x-axis, that depends on the value of d. So first case when a is negative and d is positive. So d is positive, then minus d by 4a. What will be the value of this? Minus d, it is positive, it is negative. A, it is negative, so it is going to be positive. Ratio is going to be positive. So vertex will be above this, right? Vertex is above the x-axis and graph is going to be downwards. And you know whenever discriminant is positive, roots are real. Yes, it will cut. The graph of ax square plus bx plus c is, this equation will have two roots, alpha and beta. That means it is going to be 0 for 2 times. For x is equal to alpha and x is equal to beta. But for rest of the values, of x, x belonging to all real numbers, so for rest of the values of x, this ax square plus bx plus c is going to be either positive. You can see when x will be somewhere here, x is between this. You can see ax square plus bx plus c is going to be positive. When x is somewhere here, here or here, if you take x here, then ax square plus bx plus c will be negative. All right, this is useful, that's why I'm mentioning this point here. Okay, you need to find the, sometimes you need to find the sign value of this, whether it is positive or negative. So you just figure it out using the graphs. Okay, how's the graph? Where's this point x lying, between the roots or outside the roots or on the roots? If it is on the roots, then it is going to be 0 always, right? Ax square plus bx plus c. I'm talking about ax square plus bx plus c. Okay, keep focusing on that point. Now second case, in second case, a is negative and discriminant is equal to 0. So if discriminant is equal to 0, then you can say minus d by 4a is equal to 0. So graph is downwards, but vertex is on x-axis, right? So it will touch the x-axis and graph will be downwards like this. All right. So a is negative and discriminant is less than 0. In this case, you can say ax square plus bx plus c is less than or equal to 0 for all x, right? Either this quadratic equation is always less than 0 or it is equal to 0 for these two values. Alpha is equal to beta. Roots are equal, right? So if you put the root in this equation, ax square plus bx plus c, this will become 0. And if you put any other value, then alpha, then it is going to be negative, right? Ax square plus bx plus c is going to be negative. I hope it is clear. Now the third very important case, like sixth very important case, like let's take this fourth case, this is fifth, and this is sixth. So like the third case, it was always above the x-axis. Now when discriminant is less than 0 and a is less than 0, then graph will be like this because vertex is now negative. Y coordinate of vertex is negative. You can check d is negative, so minus d is positive, and a is negative, so this ratio is going to be negative. So it is completely negative. That means ax square plus bx plus c is less than 0 for all x belonging to real numbers. All right. This is very, very important. Okay. So when is a quadratic always negative? When coefficient of x square is negative and discriminant is less than 0. I told you this point about when we were doing inequations, but there I did not explain the logic behind it. All right. So this is the logic. All right. If you express it as a perfect square, you can write in terms of perfect square also, a times of x plus b by 2a the whole square plus d by 4a. Right. So you can see a is negative, so this whole thing is negative, and d is negative, and a is negative. D is negative, a is negative. This is sorry, minus d by 4a. Minus d by 4a. So d is negative, a is negative, so d upon a will be positive. This will be positive, and because of this minus sign, it is going to be negative, right? So this whole thing is going to be negative always. Always when a is negative and d is negative, right? In this case. All right, so these were the graphs in various conditions. Let's discuss some questions based on these graphs. So it will bring some more clarity. Now in this diagram, diagram shows the graph of y is equal to ax square plus bx plus c. And we need to figure out the signs of a, b, and c and b square minus 4ac, all right? Let's see. So by looking at this graph, what can you conclude? It's a downward, right? It's downward. Let me, okay. You can see it's a downward parabola. So a is certainly negative. First of all, a is negative in this, right? So we have got this option by looking at the graph because it is downward, so a is negative, right? Now let's talk about b and c. See, what is the point c? If I take this quadratic as fx is equal to ax square plus bx plus c, then for what value of x, fx will be equal to c? If I put x is equal to 0, then f of 0 is nothing but 0 plus c, that means c. So f of 0 is 0, f of 0 is c. That means when you put x is equal to 0, the value you get is called c, is actually equal to c, and hence you can say where the graph cuts y-axis, because that is the point where x is 0, right? Where graph cuts the y-axis, that point is nothing but 0 comma c. If you put x is equal to 0, you'll get y is equal to c. So by looking at this point, you can say that this graph cuts the y-axis above the, on positive side of y-axis, right? So hence c is positive, so c must be positive. So c is positive is also correct, all right? So now would you remember that? Would you remember this point? What is the point? That f of 0 is c. So whenever graph of a parabola cuts the y-axis, that point, coordinates of that point will be 0 comma c. So if graph cuts on the positive side of y-axis, c will be positive. If it cuts on the negative side of y-axis, c will be negative. It's very simple. It doesn't matter whether graph is upwards or downwards, all right? It doesn't matter on that. So C can be positive or negative for both in upwards as well as in downwards. So I hope this point is clear, all right? Now let's talk about B. Now let's talk about B. So B, how would you figure it out about B? This vertex, x coordinate of the vertex is minus b by 2a. So minus b by 2a, this is the vertex. You can see vertex is, this is the vertex, and x coordinate of vertex is negative because it is before, it is on the negative side of x axis, all right? So minus b by 2a is less than 0, all right? Or you can say b upon a is positive, right? Simply b upon a is positive. A is negative, so if you multiply by a, then again this inequality will be reversed. So if you multiply by a, it will be also less than 0. That means b is less than 0. So this way, by comparing the x coordinate of vertex, you can figure out the value of b. All right. So if b is positive and negative, that will bring this vertex, that will move this vertex horizontally, all right? I mean, if B is positive, in this case, if B is positive, then vertex will be here, right side of y-axis. If B is negative, then vertex will be here on the left side of y-axis, all right? So this was, and what about discriminant? Is it 0? No, not at all. Discriminant is positive. Why? Because a graph cuts the x-axis at two distinct points. So if graph cuts the x-axis at two distinct points, then discriminant will be positive, all right? Discriminant is 0 when graph touches the x-axis, all right? Remember all these points. Very, very important. So now let's solve another question. Again, based on graphs. Let's see if we can do it. You think about it for a minute, then I'll explain. Getting some answers. Now you can see vertex is in first quadrant, right? This peak is given. Just look at the graph. So here's the vertex minus b by 2a. Remember the coordinates of vertex minus b by 2a minus d by 4a. Just memorize these coordinates. It's very, very important, all right? All right, so now let's take this fx, always take this quadratic as fx. Okay, it's already given in the question. Ax square plus bx plus c. Now ABC is negative. Oh, that means we need to figure out A. So A we know A is negative. What about B or C? Yes, C is positive. That also we know. And what about B? It is opposite of the different previous case, right? So okay, I'll do it again. You can see minus B by 2A is positive in this case, right side here. You can see minus B by 2A is this coordinate positive. And A is negative, multiply by this minus sign, so minus b by 2a is negative. Okay, we have multiplied by minus a and also multiply by a, so a is negative, then again inequality will be reversed, so b is positive, right? So we have got b is positive. Yeah, it should be opposite of what we were getting in the previous case. So there we were getting b less than 0, so obviously you'll get b positive in this case because everything is same. The vertex is shifted to right side of y-axis, right? So you can see yes, a into b into c is negative because two quantities are positive and one is negative, so product will be negative, all right? So yeah, perfect. So A option is correct. All right, A option is correct. Now let's check B and C and D. What are these options saying? All right. Okay. So 4A plus 3B plus 2C. What is this value? 4a plus 2b plus 3c. 4a plus 3b plus 2c. We can write this value as 4a plus 2b plus c. Always split 2c into c plus c. And remaining is what? Remaining is b and plus c. All right. Okay, now let's figure it out. Why have I written in this form 4a plus 2b plus c? Because you can see 2 is given inside the roots, between the roots. 2 is somewhere here, 2 is between the roots. So we can say value at 2 will be positive and value of 2 is nothing but f of 2, right? And f of 2, what is f of 2? Just put 2 in this. So that is 4x, 4a plus 2b plus c. So that's what I was doing. I saw this 4, so I wrote 2 here so that x will be 2, x square will be 4, all right? If I can see 9 here, then I'll take 3 here. So that means x will be 3. If I take 6, if I see 16 here, I'll take 4 with b. So that it will be x is equal, the value will become for x is equal to minus, x is equal to plus 4 or minus 4. Minus if you get minus sign here. So this is f of 2, all right, b plus c. Let's see, f of 2 is positive, right? Yes, we can see f of 2 is positive. It is above the x-axis. B is positive and c is positive. That means yes, all sum of all three values will be positive. So B option is also correct, all right? And C option is pretty straightforward. C option is nothing but f of 2 positive. Yes, it is done, already done. Now let's discuss the D option. It is written that b upon 2a is greater than 2c upon b, all right? If I cross multiply, can we cross multiply by b? Yes, we can, because b is positive. Yes, so we can cross multiply by b. So b square by 2a is greater than 4c. Can we cross multiply by 4a? 2a? Yes, but inequality will be reversed if you multiply by 2a in this inequation. Why? Because a is negative or 2a is negative, right? So okay, let's multiply by 2a, but we need to reverse the inequality. So it will be, so as to 4ac. That means it is saying that b square minus 4ac is negative. Is it? No. Clearly we can see graph is cutting the x-axis at 2 points. That means ax square plus bx plus c has real roots. And if it has real roots, then b square minus 4ac must be positive. All right. So this option is wrong. So D option is wrong in this. Only 3 options are correct. All right. Now let's move to another problem. This is another problem. It says that quadratic equation mx square minus 4mx plus 5m plus 1 is greater than 0 for all values of x. Then find m. It is written for all values of x, this quadratic is more than 0. Then what is the value of m? What are the values of m? Interval. Try this. Think about it. I'll tell you in a minute. Think about the conditions for which a quadratic is always positive. I've told you, I stressed on that point. While plotting the graphs, we discussed the point when a quadratic is always positive. Alright, so let me solve it for you. So whenever you have x, see a quadratic ax square, let me write the conditions first. Plus bx plus c is greater than 0 for all x if a is positive and d is less than 0. Alright. So that means in this equation mx square minus 9mx plus 5m plus 1, this will be more than 0 for all x belonging to real numbers if m is positive First, second discriminant is negative, which is 9m the whole square, b square minus 4a into c, 5m plus 1 is less than 0, alright. So it is 81 m square minus 20 m square, this, and minus 4m. So it is simple inequation to solve. So we'll be getting 61 m square minus 4m, all right, is less than 0. Take m common, so it is 61m minus 4 less than 0. Plot the critical points, it will be 0 and 4 by 61 plus minus plus less than 0 for this interval. So yeah, from this we'll get m belongs to 0 to 4 by 61. And inequality is there, no inequation, equality should not be there, because if we take the equality then this quadratic will become 0 also for 1 point, but we do not require this quadratic to be 0 for any x, not even for single x. It should be more than 0. And from this we are getting m belongs to 0 to infinity. We need to apply both the conditions, first and second, that means intersection of these two. So if you take intersection, it is 0 to 4 by 61 only, right? All right. Okay, will 0 be included? Because if m is 0, then this is not going to be a quadratic. Okay, let's check it. If m is equal to 0, even if it is not a quadratic, then it will become either linear or constant. If it becomes linear, then it won't be always positive. But if sometimes it happens that for coefficient of x square and coefficient of x becomes 0 simultaneously and constant term is positive, then also it will be positive always, right? So that is the case happening here. If m is 0, then you can see this is 0 into x square minus 0 into x and plus 1 is greater than 0. Yes, it is true always, right? True always. That means yes, we can take m is equal to 0 also. So m is equal to 0 is also included. So answer will be finally closed interval 0 to 4 by 61. We applied the condition that discriminant is less than 0 and coefficient of x square is positive for quadratic, but coefficient of x square we are putting 0, not for quadratic, for considering the case of linear or constant, all right? So that we checked separately, yes, and that is going to satisfy this equation. So this is also the correct answer, all right? Now simply let's solve the other one. Next question. This is again a good question. Solve it. Solve it fast. See if you're getting any answer. I'll give you 1 minute to solve it and then I'll discuss with you. Let's see if anyone answers it correctly. This quadratic equation has no real roots. That means discriminant is given less than 0. All right. C. All right. Apurv. Okay. So yes, C is correct. So whenever you have discriminant less than 0, then there are two cases, right? The third one and the sixth one. Third was this, graph will be either completely up, or the sixth case, graph will be always negative, right? That means either ax square plus bx plus c is always positive, or ax square plus bx plus c is always negative, right? But let's take this as fx is equal to ax square plus bx plus c. Then what is this value a plus b plus c represent? This value is basically value of this expression at x is equal to 1. So he is giving us one value, positive or negative, to figure out, to differentiate between these two graphs, all right? So that is nothing but f of 1. If you see f of 1 is a plus b plus c, and it is given negative. If it is negative, f of 1 is negative, that means ki all the values of fx will be negative, because if x is either always positive or always negative. So now we have got to know that this is not the case, this is the case. So all values will be negative. So f of 0 will also be negative, right? And f of 0 is what? C, right? In fact, you can make many options. You can say 4a plus 2b plus c is negative. What is this? This is f of 2. You can say f of minus 2, which is 4a minus 2b plus c. This is also negative, right? You can write infinite number of values. Okay. So whenever in the question discriminant is given negative and one of the value, either a or c or a plus b plus c, is given positive or negative, you can figure it out that it is either always positive or always negative. You can differentiate between these two cases. Now try this one. Try this one. Do it fast. This is again very simple. You mean discriminant is less than 0. All right, let's check. Expression has always same sign as of C. Okay, that means he's saying if C is positive, then ax square. Expression means he's talking about only ax square plus bx plus c, not of this equation. That is written wrongly. This should not be there. He's talking about only this expression. All right. So if this expression is always positive, graph will be like this. If this expression is always negative, then graph will be like this. In this case, you can see C is positive, and what is discriminant? Discriminant is negative. All right. Same sign as C. In this, okay. So can you see? Is it the same sign? No, no. B discriminant is less than 0 in this. So discriminant is negative, but C is positive in this case, right? Okay, what about this? In this case also, you can see C is negative and discriminant is also negative. All right. 1 minute. Discriminant has always same sign as C. So this might be the case, yes. This might be the case. When C is negative, then discriminant is always negative. This can exist, all right. But can it happen with discriminant positive? If discriminant is positive, then nothing can be said, all right. See, in this case, discriminant is positive. C is positive, right? In this case, discriminant is positive and C is negative, right? In this case, discriminant is positive and C is negative. So nothing can be concluded in these graphs, because here discriminant is positive and C is positive also and C is negative also. In these cases, discriminant is negative in this case, discriminant is positive in this case, right? And C is negative and C can be positive. C can be taken positive also, right? So this is the case in which C and D always have same sign. C is negative and discriminant is negative, all right? So this expression can have always the same sign if discriminant is less than 0, all right? Otherwise not possible. Although it is not existing in this case, but it will be valid for this case, downwards. All right, now let's move to another one. This one. This is again a very good question. Least value of 3a plus b. You're not attending a poor integration sessions. All right. Getting any answer? No. Okay, so it is giving that ax square. Let me solve it. Okay, okay. AX yesterday's session was actually very good session. I'm talking about integration session. That particular form. I explained a lot of good forms, so you can watch it later. That was a very good session. The forms were very important, which I taught in that session. These questions are just one liner, means just only logic you need to apply, no calculation at all. It's a very smart questions as well, you can say. Okay, now let me tell you, this does not have two distinct real roots. That means ax square plus bx plus c, graph of this will be, and c is positive, right? C is positive, you can see c is 6. So c is positive, so graph will not cut x-axis. It will either touch x-axis or it will be above, and it will be upwards only, because you can't make downwards graph by taking a y-intercept 6, right? It can't be. You can't make this case. And this y-intercept will be negative, right? So he's saying that roots cannot be distinct. That means by this statement, you can figure out these four graphs, first of all. Then these two will be eliminated because y-intercept is 6, all right? So these two cases will exist. By looking at these two cases, you can say this quadratic or fx is either always positive or equal to 0, right? For all values of x. So this is the condition we have got. So we've got this ax square plus bx plus 6 is always more than or equal to 0, all right, for all values of x. Now see, when will you get 3a plus b? If you take x common from this, it is xa plus b plus 6 is greater than or equal to 0. So whether it is 3a plus b or 4a plus b or 5a plus b or 6a plus b, you can get that by putting the value of x in this. You can put any value of x in this. So if you put x is equal to 3, you can write 3 into 3a plus b is more than or equal to minus 6, all right? And then you get 3a plus b will be more than or equal to minus 2. So it is always either greater than minus 2 or equal to minus 2. So the minimum value is minus 2. And equality will be there because he's saying roots are not distinct. Roots are not really, roots are not distinct. That means roots can be equal or imaginary. So that's why equality will also come there. And hence you can say that 3a plus b minimum can achieve minus 2. All right, if vertex is at 3. If vertex is at 3, it can be, right? Vertex can be anywhere. So I hope you have got it. One last question, okay? One last sum. Okay, what is your doubt, Apur? Tell me the previous question. What's your doubt? The given quadratic ax square plus bx plus c, this one, ax square plus bx plus 6, it cannot be always negative. Why? Because f of 0 is positive. If I take this fx, then f of 0 is given 6. So it cannot be always negative. It can be only always positive. It cannot be always negative because f of 0 is given 6. Na? Got it? This case will not exist because c is positive. All right. Okay, so I've finished this session now. I have another class a special class on Unacademy Plus from 5 o'clock, and we'll have another session of integration at 7 o'clock on YouTube. All right, this channel. Thank you very much for watching the videos and sessions, attending the sessions. Like and subscribe the channel. Let's crack JEE. Thank you.